Welcome students to lesson 2.4, I can divide positive and negative fractions. So we're going to use some of the knowledge that we have from multiplying fractions and use that to be able to divide. Following along on page 102 of your Glencoe Course 3 textbook, making sure that you're pausing and taking notes, rewinding and being reflective as you go along. Dividing positive and negative fractions. There's an inverse property of multiplication. It means that the product, meaning multiplication, of a number and its multiplicative inverse is 1. I like the word multiplicative inverse. It's fun. Inverse we know is kind of opposite. Multiplicative means multiply. What it really means is that if you multiply a number by its reciprocal or refliprical, as I say it, because it sounds like a somersault, you'll get to 1. For example, if I multiplied 2 by 1/2, that'd cancel and I would be at 1. If I multiplied 3 by flipping it 1/3, I'd also get 1. Notice the example here is 3/4 times 4/3. So the multiplicative inverse, or reciprocal, or refliprical, as Ms. Simmers calls it, is going to be that number flipped around. That's the multiplicative inverse. So you're just going to be asked to name a multiplicative inverse. In this case, we have negative 5/3. So we want to first write that as an improper fraction. So we know it's negative. This is where we know that the 5 represents 5 whole 3/3. So that's 5 times 3, which is 15, plus 2. So we actually get a negative 17/3. Now that's equivalent to this. The multiplicative inverse then is going to be still going to be negative, because a negative times a negative would be a positive, and it'd be a negative 3/17. And you can check, because negative 17/3 times negative 3/17, they're going to cross cancel, and you're left with just 1, product of 1. So this is your multiplicative inverse. Try a couple on your own. Knowing this one, you have to change. 3 times 2 is 6, plus 1 is 7, so that's negative 7/3. Multiplicative inverse is going to be negative 3/7. You can check negative 7/3 times negative 3/7. That's going to be 21/21, which is the same as 1. So that's our multiplicative inverse. Over here, multiplicative inverse, just flip it around. It's going to be a negative 8/5. Whole numbers, you want to put over 1 so that you can see its multiplicative inverse is going to be 1/7. It's a fun word, multiplicative inverse. Dividing fractions now. Well, maybe you've heard before dividing fractions as easy as pi. Flip the second and multiply. So to divide fractions, you actually multiply by the multiplicative inverse. So if I'm going to be dividing 4/5 by 6/7, I'm actually going to keep the front number, change division to multiplication, and flip the second number to 7/6. It's multiplicative inverse. Then I use my rules from the other day, and I can multiply straight across. That's negative 28/30. They want this in simplest form, so I find the common factors. Negative 28/30, they share a factor of 2. So I get negative 14/15 is the quotient of these two. Notice here I have some mixed numbers, so I want to change those to improper fractions first. 4 times 3 is 12, plus 2 is 14. So that's 14/3. I'm going to rewrite it just with doing the improper fractions first. So then negative 3, so we do 3 times 2, which is 6, plus 1. Keep the negative, so that's negative 7/2. Now we have division of fractions, so we're going to keep the first number, change division to multiplication, and flip the second. I see that I can cross cancel. 7 goes into 7 once, 7 goes into 14 twice, So I'm left with negative 4 over 3. Simplest form would be me changing that back to a mixed number. It's a negative. 3 goes into 4 one whole time with one of the 3 remaining. Try a couple of these on your own. Pause and continue. So some of you might know keep, change, flip. So I keep 3/4. I change division to multiplication, and I flip 1/2 to its reciprocal, 2 over 1. I can either cross cancel or multiply across. So I do 3 times 2, which is 6, over 4 times 1, which is 4. 2 goes into both of those. So I get 3 over 2, which still is improper, kind of getting messy here. 2 goes into 3 once, with one of the 2 remaining. I should know that my quotient here is going to be negative because I have a negative times a negative divided by a positive. So I keep, change division to multiplication, and I flip my second number. I'm going to cross cancel. 4 goes into 4 once, 4 goes into 8 twice. So I have negative 1 times 2 and 1 times 7. So that's my quotient. Looking to the last one, I. Remember when dividing by a whole number, we need to put the whole number as an improper fraction, so as 12 over 1, which we're also going to do with this one. So 2 times 1 is 2 plus 1, so that's a negative 3 over 2 divided by 12 over 1. So I'm going to rewrite it as division. Make sure everything's in fraction form first. Then I'm going to flip it, 3 over 2 times 1 over 12. Cross cancel, 3 goes into 3 once, 3 goes into 12 4 times. So I have negative 1 times 1 is negative 1. 2 times 4 is 8, negative 1/8. Word problem here. This says that Lena's class is making flags for the school's International Day celebration. She needs 1 1/6 feet of paper for the blue portion of the flag, of each flag. If the class has a 21-foot roll of blue paper, how many flags can she make? So obviously we're in division, so we should know there's a division problem, but we realize that we have a smaller amount we're trying to fit into a larger amount. Fitting into is wondering how many times it fits for division. So we're trying to divide 21 by 1 1/6, which is 21 divided by 1 1/6. And to do that, we have to rewrite them as improper fractions. We want everything in fraction form. Then it looks like we cross cancel. Oh, sorry, no, we didn't. Well, first, before we cross canceled, we switched to be multiplying by the multiplicative inverse. So we switched 7/6 to 6/7. Then we found the greatest common factor to cross cancel. So we had 3 times 6, which is 18, and 1 times 1, which is 1, simplified for 18. Since the word problem has a meaning, Lena's class can make 18 flags using the 21-foot roll of paper. So how about one more? How many 1 1/2 inch thick boards are in a stack that is 36 inches tall? So we're wondering how many times does this fit into this? So 36 divided by 1 1/2. How many times can that get in? So first thing I do is change them both to fraction form. 36 over 1. I like to call this my shaping step. And then divided by 3 over 2. My operate step, I like to switch them to multiplication. So I keep, I change, and I flip. Still in my operating phase, I'm going to cross cancel. 3 goes into 3 once. 3 goes into 36 12 times. So I can multiply straight across for 24 over 1. Simplifying step, 24 over 1 is the same as 24. So my answer is there are 24 boards that fit into the 36-inch tall stack. So SOS, shape, operate, simplify, and we can talk about that more in class as well. This isn't too bad. You got to have a hang on multiplying to do well at this. So make sure you go back and rewatch if you need to and get some extra practice. We'll see you soon.